So I guess we'll get started. So, okay, hello everybody. My name is Emeka, and I'm a consultant working for Financial Times in London. And I'm here to talk about what we call service-oriented operation and provisioning, which is usually because it's a nice acronym, it means SOOP. So, you know, the word lacks acronyms, so now we get one more, and hopefully it will stick. So, just in case you don't know Financial Times, you know, it's a newspaper, but they try to publish usually on the web. It's one of the few newspapers that makes money out of subscription. So when you see Financial Times, I mean, there is 250 developers there, and they develop application for mobile. We have an iPhone app, Androids on the web, obviously. So I've been there and working for one thing. What we try to do is to reduce cycle time. That means the time it takes from a business idea to have it there for the customers. And I mean, when I started 2 years ago over there, it was not uncommon to see a 6-week deployment to production. That means deploying to prod was really full of hurdles. And the goal of this project is really to reduce that time at maximum. And what we would like to be able is to really deploy to production as if it was something usual, without any big stress. Okay. Everybody wants that, really. Huh? I know it's pretty standard. So there are mainly two problems around it for us in this company. So the long feedback loop. That means people will develop on their workstation, and then the commit, it goes to the CI, and then QA, int. But unfortunately, we start to see problem in staging, or even in production, in fact. So doing this feedback loop when you have problem is very, very expensive. And I mean, really 2 weeks ago, it's happened again. So it's really what we try to avoid. What is the case? I mean, no environment are really like production. Configuration is still manual. There is not enough environment for people to test. So really deploying to production, as I say, it's an adventure. Each time when they need to do a release is, okay, let's hope it works. And hopefully the people there are, they're quite good people. They're really clever, so everybody knows well all this stuff. The database people, they know well what they're doing. The networks, they know really well what they're doing. So at the end, we succeed, but it's painful. So that's one of the problems. The other problem is more organizational friction. That means if you see the people there, that means the dev people that talk to the business will come to them, they say, okay, we need this new fantastic feature for our website. Okay, let's go, we develop them. But at the end, you need to talk to many different people to get stuff done. So the people up there, they're responsible of the delivery. But at the end, to deliver something, they need to interact with many other people. They need to interact with some people. They will create some machines. Sometimes it's really Solaris box. They go with the Solaris box still, 21st century. Configuring the network, configuring the storage, and goes up until the release management, which is just there to stop you because they're scared. And they're scared because of a good reason, because you failed, so you fail so. So deletion of responsibility. So at the end, you don't know when something failed, who is responsible. And the priority is different. So the people there, the priority is to get stuff out. The release management is to not change anything. And you get a conflict there. Okay. So the vision is reverting that diagram. That means to give the people who deliver the value, to give them full control, but also full responsibility. That means you have something you can deliver automatically. You're responsible of what you're delivering, and the people there across, they're just there to provide knowledge and also to provide automation. That means instead of asking for someone for networking config, they're there to help you to put the right automatic config of your network inside what you deliver. And we want also to deliver the same way locally, that means on your workstation, on VMware, I mean Financial Times and this kind of VMware private cloud, and also on external clouds. So that's the vision. So now I will spend the rest of the time to explain you how we try to achieve this, mainly using Puppet. And let's say with a model around Puppet that is, I guess, slightly original, and I'll be happy to get some questions and challenges around that thing. Okay. So one of the first things we wanted to achieve is that when you hear the talk here, people tell you about Puppet, and then they tell you about nodes. So they will tell you, okay, we have these nodes, and for example, using ENC, we will associate some classes to this node, and we spin up another node, and it's all around the Puppet master and the nodes. And what we've done, we have added a middle layer there. I mean, we talk about services. So what we deploy, we don't deploy nodes, we deploy services. Okay. And if you remember the theme before, what they deploy is services. Everything is encapsulated inside this box here. A service is an artifact. It could be a tarball. We use RPM because we work with Red Hat, but we don't care. That thing is versioned and is built during your build process. So when you modify some code, you do a build, we use Maven, but again, that's not important. That Maven will build this artifact, this RPM, and that's what we deploy. So we deploy services. And we do deploy services inside an environment, and an environment is just its domains. In fact, is uniquely identified with a domain name. Okay. So, for example, here is the membership test domain. You could have the membership CI domain, the foobar, blah, blah domain, my local test domain. The domain is just a key that allow you to put things together. But at the end, the important bits are the services that you deploy. Okay. So now let's take a look inside this service. For me, you can ask questions when you want also. That's fine. What is the service? Call it a service definition. It's a package. As I said, it's delivered as an RPM. And what does it contain? It contains Puppet modules. So what I call service definition is just a directory, and each entry in the directory is a Puppet module. Okay? It's what we deliver. You have different Puppet modules inside your service. You have modules that come from a library. They could come from Forge, Puppet Forge, Puppet Lab Forge. There's also version. And you have another one module, which is really your service module. So the developer, in fact, they work more on this one. Okay? They will use generic modules, certain versions, and then they will develop their own module here. For example, imagine that I have a web app, which is 3 tiers, and maybe I have an HTTPD, a Tomcat database, and you will have a HTTPD here, Tomcat database. Then the application will be a WoW file. The WoW file will be also packaged and put inside this module here. So when we deliver this service, it contains how to deploy your service. It also contains your application. It contains everything. That thing we deployed, and it should work. Another thing is, I don't know who is familiar with Puppet, please.
Sorry, I just got a question. You talked about the modules, and so there's the modules on the left-hand side and the modules on the right-hand side. If I understand correctly, you're kind of saying that the ones on the left-hand side are kind of a standardized stack that all the applications can go on top of.
Yes, exactly.
Okay. And then on the right is kind of more specific to the application.
Yes, yes.
All right. Now, then you mentioned, I guess what I don't get, all of them are in one RPM,
yes.
And that RPM is produced during the build process.
Yes.
Okay. And so then you talk about the Puppet manifests, and how does that relate to the Puppet manifest?
So these, I mean, each module are Puppet modules. So Puppet modules, so they contain their own manifest, etc. This one is also a Puppet module. I just make it bigger because that's the kind of custom module that you provide with your service. This module will configure the other module. They will use it.
Okay, I guess I'm not, and this would just be my own ignorance here,
demonstration. It was like this before. You will see that the way we deploy this service, we deploy it on a Puppet Master at the end. And we wanted each service to be able to use different versions of the modules. So for example, I have an access service that uses HTTPD module. Maybe this module is version 1. Maybe there is in the same domain, there is another service also using HTTPD. But maybe the team is kind of like cutting edge Puppet modules. They will use version 1.1.0 on the same Puppet Master. So in fact, you want these two modules, even if they both call HTTPD, they'll be different for service 1 and service B. You see? So you encapsulate with your service the module that you use, whatever the version. And
okay, yeah. So what you're saying is you're not packaging HTTPD with Tomcat into a single RPM. You're packaging the module definition for HTTPD.
Yes, the module.
Tomcat into an RPM.
Yeah,
okay,
yeah, yeah.
I get it now.
Yeah, the whole module. There is no binaries here beside maybe beside the WAV file.
Okay,
okay,
I got it.
Okay, and each service are in their own Puppet environment. That means each service is really segregated from the other ones. So you can deploy. Again, the goal is to remove bottlenecks. That means you want to be able to deploy services without impacting other running services. And you want the teams to be able to to be free to do the upgrades they want. You don't want to say, okay, here I have a Puppet Master, I have two services, and oh, I would like to upgrade that service. Oh, so you cannot because you're sharing modules. You need to wait that everybody agree on which module to use. So that's a bottleneck. So we try to avoid that. Okay, so that's the whole service definition. So the next step, so everything is service, we deploy the service. The next step is the Puppet Master itself is part of the service. Okay? So we have a controller service, which is kind of a mandatory service. This controller service contains the definition of a Puppet Master, so how to spin out as Puppet Master, but also the DNS for the domain, since each domain has its own DNS, and other services, for example, the NAJAS monitoring. So as a team, a development team, I develop a service. When I want to test it, I will deploy my service plus the controller service. And that controller service includes what FT deemed to be the thing that we need to put something in production. Okay? But I don't need to ask permission to deploy it. So I'm able to deploy an environment locally or on the VMware stack really far up to production if I have the right to do it by myself, and it will automatically spin out the Puppet Master. It will install everything on it, and then it will also install my service. So there is no, as I said, no sacred cow. It's not as if the Puppet Master was something so special that, okay, we need to protect it. So again, it's one less bottleneck. So I don't need to ask permission to spin out the Puppet Master and to configure my service. Okay. So we need a bootstrap, obviously, because you need the Puppet Master to configure your domain, and your Puppet Master is configured with a service. Okay. So the bootstrap is like this. Every VM that we spin out is a vanilla VM that contains a small library. We call it FT Cloud Base. That library gives you a script. It's a simple bash script. It's not really big. That is very, very thin. And there are two types of nodes. There are the standalone node, and there are the client node. It's kind of obvious. A standalone node can configure by itself. A client node needs a master to configure itself. So we spin out the node, currently still manually to be, that is now we soon plug that into the app of VMware. And on each node we run a command. So if it's standalone, we run ft cloud init standalone, use standalone node. We give a cert name, because we use cert name to identify node. And then on the standalone, we give the list of services we want to deploy. And then it starts to become this service. Okay.
And what manages the, so if a particular service includes a stack, say HTTPD version X, application container version Y, and you're loading multiple services on a given
Yeah, I mean, but still using RPM. The RPM will install each service under a directory I will show you. And since each service runs its own module path, the module path configuration point to the right place in the directory. So each module under that service is part of the module path.
Okay, so everybody's installing to their own module path,
Yeah.
all stuff very much in there. And how about shared resources like TCP ports, that kind of stuff? Who gets 480? Or does nobody get 480?
Okay, I didn't mention it, but it's a very good question. As a constraint from the beginning, and also to avoid bottleneck, VM are not shared between services. Okay. So, for example, if I have two products, two web, we don't share. I don't know if you've seen the keynote this morning, the VMware keynote. It really mentioned that now the virtual machine is there to support maybe one app. You don't need to share because you can make your virtual machine very small anyway. So I'd rather have many small virtual machines that do one thing than having a large one, and then you have maybe your Tomcat with two services. Then what's happening? Do I need to ask permission to team B to restart the Tomcat that share with us, etc.? So there is a slight waste in resource, but we gain in cycle time.
So you are showing here, though, like controller service, access service. So there are multiple services on a given host, but this is services owned by a single team, and therefore they're coordinating amongst themselves.
Yeah. For the client, it's kind of easier. So declaring client, again the cert name, and then the host name of the Puppet master. It's the only place where we use host name. It's part of the Bootstrap. After that, all nodes are identified by the cert name. The cert name has a meaning, and then it says access service, the app node. Okay. Time's running. So, because we do this kind of bootstrap, we just use a shell script. It's very thin, so we can run it locally using vagrants. It's really easy to build an OVF with it. That's the next step for us. We build an OVF that will spin out all the nodes on VMware and easily run the bootstrap. We can easily generate a CloudFormation JSON file that also will do the little bootstrap. It's always the same. We don't care about which VM technology you use at the end. Okay, so we're really on top of it. Just exactly. So the way it is installed under the Puppet master is under etc Puppet services, and each service has its own subdirectory, and under that you have the modules. Okay, and the module path will be etc Puppet services environment. Yeah. The environment is annoying because environment is some overloaded word. The environment corresponds to the service name. Okay, so when the client in it, it will set the PuppetConf environment to be the name of the service. So if you go back here, running that will set the environment parameter inside your PuppetConf to access. And that gets sent to the Puppet master. At the end, if you see these appends, they get installed on the Puppet master, huh? Just to be clear. So let's go back to the service definition, something I didn't mention. So I did mention that the service definition, which is this package that we deploy, contains everything, including node definition and config. Okay. So let's go to some details here. We don't use ENC. I'm not religious about it, but we didn't need to use it. Okay. The host name that we have are quite ugly. It's kind of like this FT apps 123 LVPI UKP, which means it's a Linux virtual on Park Royal data center in UK in a production box. And FT apps means you run an app, but at the end we don't really know what's content is at the end. So the next step would be to use ENC to grab and to match the host name and to get a list of class to deploy your Puppet master. But also, I wanted people to have a meaningful name in DNS. So I don't want people to use FTApps123. For me, it means nothing. whether people using Access App 01 is the app node 01 for the Access service. So, I mean, if you have a node name containing class, that's just a node file. So at the end, you don't need, in that case, the way we organize our services, we don't really need ENC. But okay, I've seen the demo of just earlier, so maybe with Puppet 3 we change our mind because there is new stuff coming that are quite interesting. But currently we didn't need it. And also in the external node classifier, I didn't like the external because I want everything to be configured inside the service and less things configured externally by other people, the people who are responsible to deliver the service. And so we don't need to use that. There is a drawback, unfortunately, is that you cannot change easily your node names. So when you put a cert name, you'll get all the certificates, etc. are calculated, and then if you want to changing, it's a little annoying. You need to do the cleanup, etc. But it's not expected that people will change that often. And for the configuration part, we use Hiera. It's not really original. The only thing is that we have improved slightly the YAML backend to be able to use several directories. So we have a global configuration, which is shared for Financial Times. There are people who know exactly what are our global DNS, for example, or things like this. Then there is another configuration which is inside the RPM. So all the default for a service are encapsulated inside the RPM. And then you have a domain environment level configuration. So if you need to override something or read something that is specific to that environment. And then we have factors that allow to just select the right YAML file for your configuration. So the global configuration is also an RPM because that's one of the things that it's not the development people who knows the content of that file. They don't know about it. It's really global to the organization. And it's good like this because there is things that are purely infrastructure that the developer really don't want to take care of. So that's also an RPM that get deployed. Okay. No, that's it. Okay, so good. I don't know if it comes across really well. The thing that's the optimization is really on the cycle time. That's really the goal. We're not optimizing the number of nodes. I'd rather really waste some VMs that get team deployed rapidly. Also, I want teams to be responsible to deploy the things and also to have the power to do it and the responsibility. So at the end, this RPM, this service RPM, get deployed locally on your machine. You can test already everything here. That means when I deploy a domain on my local machine, I deploy the Puppet master with the controller service. I can see the nudges, I can look at it. If I need to change my nudges config in my service, I can really check that here. We also deploy a local Splunk server, so I can check my Splunk config. And when we start to have more kind of central services inside your domain, I can test everything here. So I can have a really short feedback loop. And then when I'm happy, I commit. So you commit after having checked your full environment, not afterwards. So you stop kind of polluting your Git repository with stuff that you haven't tested because, oh, I cannot test locally because I don't have my Puppet master. Yes, you have a Puppet master. What you deploy locally is the same as what you will deploy in your CI, your QA, going up the stack to prod. So what we expect is that when you deploy this RPM, which is versioned to production, hopefully you have run that dozen of times. So when you do it in production, it's not a surprise, it should work. The only different thing is that, okay, we still uncertainty around the global config. Maybe the global config was wrong and the DNS IP address has changed, something like this. But yeah.
So when you do upgrades, you're just installing a later version of these RPMs that have gone through all this testing process. Do you also do like continuous integration testing of the RPMs to test like the services?
Yeah, yeah. If you do I mean, if you look at the
You had a slide way back.
here, that's if I want an environment with an exact list of versions. When you see here, you don't put the versions. Basically, what it does, the 3 lines, is will be 3 yum install. Huh? What's what the script does. So if you don't put the version, it will always take the last version. So our CI, in fact, is we spun out an environment using that without specifying the version, and then we have on Hill Pro, we just run an agent on the Puppet Master, and then we just run ftcloud update. There are other commands to this command. So ftcloud update, which is just grab the config and run an update, kick all the client. So that's the way we do the continuous integration.
Cool. What do you do to manage, so as that upgrade rolls, so you're upgrading, you deploy your RPMs to the Puppet Master to upgrade to a new version. Are you always spinning new images or new things, or are you upgrading in place? In other words, if you need to take, if you're going to update an app or file on a particular box,
Yeah.
are you doing that in place? It would imply that you've got a new service because it's a new version.
Yeah.
You've installed Puppet modules for the new version.
Yeah.
Are you just letting Puppet convergence run its course, or are you orchestrating through that?
People have the choice. I mean, one of the teams, they want to do a red-green deployment. So they want to deploy a new environment and then just switch on the load balancer. Okay. If so, okay, they can do that. The model works like this. Otherwise, we do the update in place. So you get new modules, and then you get a Puppet update, and you get everything.
What are you using? Are you using any tools in collective solve, fabric, blah, whatever to do that?
Currently, not much. We use M Collective to, I mean, we have a Jenkins nodes we can deploy. In the modules that we have a Jenkins. We use M Collective to kind of synchronize with the Jenkins. But the deployment is really just Puppet kicks. So get the new RPM, kick. Then the agent, go to Puppet Master, get the new stuff, then run. Yeah. Okay, did I do all done?
Well, one of the things about managing the environmental configuration, so the differences between, say, the stack should be roughly the same as it goes from dev to a production.
Yeah.
The stack's going to be the same, right? Your service is going to be the same.
Yeah.
But there's environmental information that's getting pulled in, right?
Yeah.
For, what is that again?
So we use Hiera for that. So you have global config for the full organization.
Okay.
You have default Hiera in the services, and then you can have also as RPM specific configuration for your environments.
I'm sorry, here is running externally, or is that?
The global is external.
Okay.
The service base is internal. Still in the service.
So it's internal that applies as part of your service package?
Yes, yes,
So,
yes. Which is
so is each of the environments then specified in?
it is a weakness. As a developer, I say we prefer put it externally. I say no, because FT on ST is really small. It's not as if, I mean, they make maybe a lot of noise, but at the end there are 3 data centers. We have 300 VMs now, but most of them are dev VMs. It's not huge. Okay. So currently we still put service differences inside the service. We haven't seen a use to put it completely outside. I mean, it would be purer if it was outside. Totally agree. But when you ask a question to people, I say, yeah, they just put it there and they're happy.
And some version control. And
It's under version control, and I mean, it's all service. We want, if that node is deployed in that data center, we know what to do. It's there. So I asked them the question. It's what they wanted. Yeah. I think that's it, basically. I think the original bit is more around the way we use service, and we try to avoid the middleman.